Okay, the opposite. So I want to talk about inverse operations. Can you give me some examples? It would be a pair of operations that are opposites or inverses of each other. Liam? Those are additive inverses of each other, but I'm talking about operations. So mathematical operations you do, like addition and subtraction, multiplication and division,
Square rooting and like squaring something.
a square root and squaring something. So like raised to the power of 2.
Funky?
This one's funky. Oh. Sure. Okay. You're supposed to go to Mr. Johnson. Okay, any other inverse operations out there?
All of the square root and square can be like adding and
Yeah, we talked about that in chapter 5, and Mickey called it the nth root. I think that would be great. The nth root, and then like raising it to the n power. Cool. Okay, add to this list of things you know that undo each other. Exponentials and logarithms. Now, when I say exponentials, what I'm talking about is, like, most of the time we use it when we're doing variable exponents. Oops, variable exponents. So that's why we most commonly see this, or that's why yesterday when I talked about the log is really like a man-made thing, right? Mathematicians decided to call it a log. We decided to write it that weird way that we write it, and we all just agreed to what that means. It's asking the question, what is the exponent that you need? Okay. So exponential and logs undo each other. Okay, so we have two properties that I'm going to have you write down in your notes, and they look a lot worse than they actually are when you use them. It does look really bad, I agree. There's a lot of little letters over there.
I said that.
Okay, so remember that logs undo variable exponents. Cannot say that enough. And these are our two inverse properties. What's that?
Little b. There's a even smaller b.
Yeah, that's its base. Log base b.
Is that x exponent of b?
This?
Yeah.
No, that's the thing you're taking the log of.
Oh, there.
Remember, b is just your like subscripted base for your log. So like over here it could be 5 or 6 or 7 or 2, and then the x is the thing you're taking the log of. Okay, now I do have a little fill in the blank there, which really confused some of my students last hour. So I'm going to try to remember to take out for next year. But it's just like, question mark, what is the answer, right? Just fill in the blank. It doesn't mean anything right now. We're going to put something in it. Okay, so let's look on this left side. We have this property that has a lot of stuff going on. It says log base b of b to the x. Okay. Now, I'm going to think about it like I would have yesterday. Put my thought bubble up there. This is what's happening in my brain, right? Okay, if it's log base b, then the base to my exponent is b. And the answer to the log, this fill in the blank, should be an exponent, right? The answer to a log is an exponent. So I'm just going to put my blank up there. It's saying b to the what equals the thing that I'm taking the log of, which happens to be b to the x. So what would you say has to be in the blank? X. Okay. Basically, remember what we're saying. Logs undo exponents. So if you put an exponential with the same base in a log with that base, they undo each other and you just get the exponent. Let me show you an example with numbers. The log base 5 of 5 squared is equal to
2.
2. Because if I rewrite this, BC for me means because. If I rewrite this, I'm saying 5 squared equals 5 squared. Do you agree with that?
Yes.
You sure do. Don't make that any harder than it is. Okay, it makes total sense. Okay, so let's try another one. Let's say the log base 8 of 8 to the 14th. The answer is 14. The log base 8 of 8 to the x.
X.
The log base 6 of 6 to the x plus 1.
X plus 1.
It just equals the exponent. Everything cancels out. Now let me put a hard one up here. Harder one. The log base 5 of 25 to the x.
Plus 1.
Well, you can't cancel them, right?
Right.
When do you get to cancel them right away? As long as the base is the same. So, like, initially you might be like, whoa, whoa, whoa. Let's slow down. We can't cancel this. However, take a second look at this. Can you rewrite 25
Yes.
so that it has the same base? We can rewrite it as
Yes.
5 squared, Lexi says. This is log base 5 of 5 squared to the x. And then can we cancel the bases?
Yes.
Yeah, so what's left over? 2x. Okay, that's all it is.
What does log stand
It's the answer to the question, what is the exponent?
for? And so you always have to write L's lowercase.
Yes. If you write capital L's, it doesn't bother me. But it is lowercase log. Okay, well that's one property. The other property looks like b to the log base b of x. What do you suppose that might equal? Someone said it? X. It's the same thing. They're going to undo each other. An exponential expression with a base of b raised to a log with the same base b is going to cancel each other out, and we're just going to get x. Okay. Now that makes sense because this, do you agree, is an exponential form? I have a base and an exponent and it equals some answer. If I were to change that into log form, I would have to say the log, what's the base to your exponential? B, log base B, of what value? Of x must equal, the answer to a logarithm is an exponent, so it must equal log base B of x. Is that statement true? Yes. So if you rewrite it in the other form, they cancel, like they just make the statements true. Don't overthink this one. Okay, you just need to have matching bases for them to cancel. So I could make up some examples. Let's do 7 to the log base 7 of 8x. The answer is 8x. I'm doing the old version. 2 to the log base 2 of x plus 1. X plus 1. E to the natural log of 5. 5. Because what is the base of this natural log? There's a secret E right there that you don't have to write. So then they cancel, and it's 5. Okay? That's all they are. Yes, ma'am. Yes, if you did 10 log 6, that would be 6. Because this one has a secret 10 that then cancels. Not a secret 10, everybody knows. Okay. Okay, not too bad, right?
Right, that's it, right?
One more thing. Now we did this in first semester. We found inverses. Does anybody remember what you have to do to find an inverse? Sierra? Hi, tens. Switch X and Y. Does that sound familiar?
Yeah.
Oh, so you all knew that?
No.
Oh, okay. I was going to say high tens all the way around. Okay, you got to switch X and Y. Now, it does not matter how your function or relation is represented to you. You could switch X and Y in a table. You could switch X and Y, I'm going to say, on a graph, right? Switch the X and Y coordinates. Or you can switch X and Y in an equation. And that's what we're going to look at, the equation version. Now the equation version has this little tweak to it. Not only do you have to switch X and Y, but then you have to solve for Y. Because you want your equation to look like Y equals. That's how we always write things, right? So if you switch X and Y, then you still got to go back and solve for Y. Okay. So, gosh, man, this is like the 3rd time I've written this on the board. So it must be really important going forward. Exponential and logarithmic functions undo each other. So remember that. If you get down to something and you have to solve for your y and it's in an exponent, you're going to need a log. Vice versa. If you get down and you got to solve for y and it's trapped in a log, you're going to need an exponent. Okay. We'll do this one first. Y equals 5 to the x. Okay, well, first step to finding an inverse. Switch X and Y. So that's going to look like x equals 5 to the y. And then we have to solve for y. But y is trapped up in an exponent. So I can't multiply or divide to get it out of there. It's not multiplication or division. That's not its inverse operation. So what's the inverse operation to something exponential? Logs. We're going to change it into a log. Okay. So this is going to be log. I can't even look at you anymore. It's only because he's laughing.
I'm good.
What is the base for your log? Base 5. Because it's whatever the base to the exponent is, right? Now, what comes after log base 5? What are you taking the log of? Well, the answer to the log has to be what? An exponent. What's your exponent? Y. So what are you taking log base 5 of? X. When you rearrange it, like when we think back to yesterday, we had that statement like log base b of y equals x only if b to the x equals y. You have to put those things in the right location. But just like yesterday, they don't come out in order. The easiest way to rewrite it in log form is to remember that your exponent is the thing on the other side because that's the answer to the log. So the base goes in the bottom, and the thing that your answer is, that's the thing you're taking the log of. But do you see that now? You solved for y. Y is all by itself. Y equals log base 5 of x. So the logarithmic function with base 5 is the inverse to an exponential function base 5. Brilliant. That's your answer. Let's do the next one. What are we going to do first?
Let's fly.
Flip flop x and y. Well, I'm supposed to solve for y, but y is kind of now trapped inside of a parentheses behind a log. So it's currently in log form. I've got to change it into exponent form. How do you break into logs? Through their inverses, which are exponential functions. So what's our base to our exponential function? What's the base to that log? That's ln natural log, that's base e. We learned that yesterday. It's a special one. So we're going to say e to the... Nope, that doesn't go in order. What's the...
X.
The answer to the log is the exponent. So it's e to the x equals y plus 5. Can you solve for y? Subtract 5. Now that 5 is like down on the regular line of text, not up in the exponent. Okay, so remember, when you have something that's in log form, the thing that the log equals, this is going to turn into your exponent, right? Because the answer to a log is your exponent. So then that shows up over there in the exponent. In the other version, when you have a variable in your exponent, that needs to be the answer to the log as you're rearranging it. So the answer to the log is y. Okay, let's do 2 more and then you'll have some time to work. We'll do y equals e to the x plus 3. Start by switching x and y. You have to solve for y, but it is trapped in an exponent. So you're going to rewrite it as a log. So this is exponential. So we're going to turn it into a log. If the base to our exponent is e, we're going to use ln, natural log. The natural log of what value? X equals y plus 3. Remember, the answer to the log will be your exponent, so your y plus 3 becomes your answer to your log. Now you still have to solve for y, so you're going to subtract 3 from both sides. This can be a little bit tricky. If there are no parentheses right there, I would assume that minus 3 is after the natural log of x. Like the only thing you're taking the natural log of is x. So if you ever mean for it to be in a set of parentheses, you better be drawing your parentheses. Okay. You might sometimes see it written like this, where someone clarifies that only x is behind the log. Okay, but that 3 was subtracted after we did natural log.
I just wrote -3 plus
Yep, that's fine. -3 plus natural log x is great. Okay, last one. See if you can do it. Y equals log base 5 of x minus 1. Switch x and y. Solve for y. And something in log form, I'm going to change it to exponent. 5 to the x equals y minus 1. y equals 5 to the x plus 1. Inverse. So every log function has an inverse that's exponential. Every exponential function has an inverse that's logarithmic. You should see a connection between the bases. Like this is base e in exponential, and then it's natural log. If I had base 5 as a log, then I'm going to have base 5 as exponential. So you're going to see that over and over again. Okay, your homework assignment is on page 314. You know, as you're doing these problems, rather than a race to get them finished, really take the time to think about logs, because that's the weirdest part about it all. We have to understand what a log means, right? And the log is asking the question, what's the exponent you need? Okay, so the answer to a log is an exponent. Go ahead and get started.